Hi guys, welcome back to another video of me solving integrals, and today I have this very fun integral to share with you guys. Well, why don't let's get into the question. So if you take your time and look at this integral, then you might be thinking, can't we just do some fancy u sub, like let u be the denominator? No, that doesn't work. Or maybe you might be thinking more complex, like maybe using Euler's identity, substituting cosine and sine into those e to the power of ix things. But these two methods both make this more complicated. Well, if you have a look at my other videos, then you can tell that I have a pretty special way of doing these types of integrals, which is I make the original integral I, and then I create another integral j, and then I add them, I subtract them, and then hope for the best. Well, that's actually what I'm going to do. So I'm going to let I be this integral, and the top is cosine of cubed. And I'll let j be the integral of, the denominator will actually stay the same, and the numerator I'll make it into sine cubed. Now, you may be wondering for j why I let the numerator be sine cubed. Well, it's because the denominator we have cosine and sine, and wouldn't it be nice if the top would also be cosine and sine? Then maybe there would be some cancellations. So, continuing on, why don't we first try to add I and j up? So it becomes the integral of, the top is sine cubed plus cosine cubed, and the bottom is same denominator, it stays the same. So this is equal to, the top we can factorize it to make it become, the first term is sine x plus cosine of x, and then the second term is sine squared of x minus sine x cosine x plus cosine squared of x, and the bottom stays the same. Okay, well look, cancellations, that and that cancel. Beautiful. So this is equal to the integral of sine squared plus cosine squared is 1 minus sine x cosine x is 1/2 times sine of 2x. And this is a super easy integral. This will be equal to x minus, you use the chain rule, 1/4 times cosine of 2x. But the derivative of cosine is negative sign, so we need to change this to a plus. And of course, don't forget the plus c. We need I minus j to figure out I, right? So why don't we try to figure out I minus j? So it's equal to the integral of and we can also factor the top. So the first term is cosine of x minus sine of x, and the second term is cosine squared of x plus sine x cosine x plus sine squared of x, and the bottom is cosine x plus sine x. Well, this time there's no cancellations. So what do? Well, we can obviously first clean this up. So it will be the integral of cosine squared plus sine squared is 1 plus, that is just 1 over 2 sine of 2x. And the bottom stays the same. Now, in these situations, we will normally multiply the top and bottom by cosine x plus sine or cosine x minus sine. The reason why we do that is so we can change all of these expressions into cosine of 2x or sine of 2x, which is easy to manipulate as we can do u sub. But the question is, would you want the things or the things in terms of 2x to be on the bottom or to be on the top? Well, if it's on the top, it's significantly easier to do u sub. So we're going to multiply the top and bottom by cosine x plus sine x, okay? So this would equal to the integral of, the top is cosine squared minus sine squared, which is cosine of 2x. And then multiply by 1 plus 1/2 times sine of 2x. And then the bottom will be cosine x plus sine x squared, which is equal to cosine squared of x plus sine squared of x is 1. In the middle term, it will be sine of 2x. So the bottom is just 1 plus sine of 2x. Well, now we can actually do u sub. So we can let u be sine of 2x. Du is equal to 2 cosine of 2x dx. And we have cosine of 2x dx, but we need a 2, but then we have to divide by a 2. So if you remember this substitution in your head, I'll just erase it now. This integral will become 1/2 times the integral of, well, this and that is the du. So it's 1 plus 1/2 times sine of 2x, which is the u, and the bottom is 1 plus the u, du. Well, we don't like this 1/2, right? Well, that's actually an easy fix, because we can just make it to a 1 we like. 2 plus u. But then, this outside we need to multiply by another 1/2, making it 1/4. Well, this is actually super easy to solve because we can change this 2 into 1 plus 1. And we can now do partial fractions. So it's equal to 1/4 times the integral of. I'm going to write this term first because it's a bit more classical. So 1 plus this, which is 1 over 1 plus u du, which is equal to 1/4 times u plus ln of absolute value 1 plus u, which is equal to 1/4 times, the u was sine of 2x, so it's sine of 2x, plus ln, we don't need the absolute value because 1 plus sine of 2x will always be positive, so it's just brackets now, 1 plus sine of 2x. And don't forget the plus c. Okay, and now we have a simultaneous, so to figure out I, then we need to add these two and divide it by 2. So I will be 1/2 times that plus that, which is x plus and then add it with, I will open this. Let's see. Well, we saw this is our final answer. I is, we can open this, so it's 1 over 2x plus this times that times that. The coefficient will always be 1 over 8. So we can factor out a 1 over 8, and the inside will be cosine of 2x plus sine of 2x plus ln of 1 plus sine of 2x. And just a little note, I asked Wolfram Alpha to do this, and he came up with the exact same answer. Well, thank you guys so much for watching, and if you enjoy my videos, please consider liking and subscribing. If you want to master something, teach it.